meeting is now live streaming on Facebook.
Here we are. Yes, we are indeed live. Okay. Well, not a very elegant start, but my name is Kathy. I'm with the Friends of the Planetarium, and we are trying to bring to you a little bit of a live chat with two distinguished astronomers. We have our Sethanne Howard. Dr. Sethanne Howard is going to talk to us about asteroids, near Earth and otherwise today. And Dr. Alice Monet, another friend of the planetarium, is going to help out with that. And hopefully we'll be able to make this work and you'll be able to ask questions at the end of this. So I am going to hide myself and I'm going to have you folks go ahead and start.
Okay, well, so glad we're finally streaming, and I'm really glad to be here. I'm Alice Monet, an astronomer. Spent most of my time at the Naval Observatory, 34 years at the Naval Observatory, and retired a few years ago and have been working with the Friends of the Planetarium ever since. And I'm really happy to be here with my good friend, Dr. Sethanne Howard, also retired from the Naval Observatory and a few other places. And I'm really looking forward to your presentation, Sethanne. It looks great.
Oh, thank you. Yeah. Hi, Alice. Shall we start?
Oh, yeah.
Yeah. Well, I think I need to share my screen and bring up the PowerPoint. It's a PowerPoint talk. And this should put it on. It's supposed to go up to there. Does that look right on
Yep.
Facebook?
Looks good.
Okay, impacting the Earth. And if you don't know the reference, don't panic because you always carry a towel. That's from Hitchhiker's Guide to the Galaxy. It's an old-fashioned thing. Us old fogies know about it. You young ones may not have read that series of science fiction books. They're delightful. It's a trilogy of 4 books or 3 books of a 4-book series. Any rate, if we're going to start with asteroids, we have to talk about what they are. And down at the bottom of the screen are actual photos of real asteroids taken by planetary missions that have flown by them and taken photographs. I don't remember the names of these particular asteroids, but we haven't.
Well, got Ida. You got Ida there.
Ida
on the left side, and Gaspra is on the right.
There's Ida.
Yep.
There's Gaspra.
Yep.
I'm going to talk about Ida in a minute.
Great.
And
not quite sure about the other 2.
That's good. But an asteroid is officially a minor or dwarf planet orbiting the sun. Simple, right? Well, it could be simple. If you look at it through a telescope on Earth, it looks like a star. You don't see a shape to it. You have to get up close. They're too small. So it looks star-like through a telescope. And it's a small chunk of very old rock. Most of them go back to the formation of the solar system. And it's made of rock, metal, and sometimes even sugar, water, other organic compounds. The first asteroid was discovered, is number 1, so it's called 1 series. And they originally thought in the 1800s, the first half of the 1800s that it was a new planet. And then they found out that it wasn't a new planet. After all, it was a dwarf planet, but it does contain water, which is interesting. And its diameter is given there. It's almost 1,000 kilometers in diameter. It was discovered by Giuseppe Piazzi at Palermo Astronomical Observatory in 1801. He was a Catholic priest who worked, and they founded the observatory and he ran it. They founded the observatory for him. But my favorite asteroid of all of them is asteroid 46612 B612, which is, or B612, found and named for the Little Prince. And those of you that have ever read The Little Prince, he lives on asteroid B612. And that's my favorite. There is an asteroid out there named for him, which I think is
excellent.
But I think that's wonderful. Yeah. It was discovered in 1993. And some asteroids even have little baby asteroids circling around them. And that's Ida. And then Dactyl is shown down here, right? See the size comparison? That's Ida, and this is Dactyl. So they just, Ida goes around, Dactyl goes around Ida. So asteroids have even little astrodettes. Now, in case you didn't know it, now and then the Earth has more than one moon. And we have a new mini moon right now orbiting the Earth with our regular moon. It's very tiny. It's only 6 to 12 feet in diameter, and it will not be around for long. It's going to leave us in the summer or June time frame, but it sort of comes in, the Earth captures it, and then it for a little while, and then it leaves. So now and then the Earth has more than one moon. In this case, it's a mini moon, but that's okay. Where do they hang out? Some of them, in fact, a lot of them hang out in the main asteroid belt between the planet Mars and Jupiter. There's the asteroid belt. If you can see my arrow, I think you can.
Oh yeah.
And there are Jupiter is the boss of the solar system. It's really big. And so there are asteroids that hang out in Jupiter's orbit, controlled by Jupiter. And if you imagine everybody's going around counterclockwise, in the astronomy world, things go counterclockwise. And if you imagine it's going counterclockwise, these lead Jupiter and these follow Jupiter as Jupiter goes around in its orbit. And I have a not up to date, but a figure that shows each dot is a known asteroid. And you can see all the dots of all the asteroids we know about. And this is the asteroid belt. And here's Jupiter. And the ones that lead Jupiter are called the Greeks. And ones that trail Jupiter, because they lost the Trojan War, are called the Trojans. And then all the white dots are the asteroid belt. Isn't that amazing?
That's great. That is a great illustration.
And then there are the outer asteroids. If you look and see the orbit of Jupiter in here, you see the Trojans in the very bright, bright, bright part. And then Saturn, Uranus, and Neptune. And then all these dwarf planet asteroids out here. And the reason that there are a whole bunch of them, they're called Kuiper belt objects. And there are a whole bunch of them. And it turns out there's Pluto right there, right now. Sort of right now, give or take a few years. But there's Pluto, and that's one reason Pluto got kicked out of the solar system, because it's like all these others. It's very similar. And so if you had to memorize the names of all the planets in the solar system, you'd have to add all these in too. And we don't want to do that. We're lazy. So we'll just remember 8. This is the astronaut Bennu, which is, and this is the highest resolution photograph ever taken of a planetary object. This picture here, and it was taken by the mission OSIRIS-REx 3 to 5 kilometers away from the surface of Bennu. And the resolution is, each pixel on the camera covers 5 centimeters on the surface. That's just, to astronomers, that's amazing. The picture in the lower left is OSIRIS-REx coming close to Bennu and watching it rotate. And OSIRIS-REx has a mission, and its mission is to land on Bennu ultimately and return samples in 2023 to Earth. It's supposed to come back to Earth and return samples. And Bennu was named by a 3rd grader who actually thought the mission shape of OSIRIS-REx looked like a swan type of flamingo. And because it looked like a flamingo, the Egyptian word for flamingo is Bennu. So that's it. The 3rd grader thought that up. I thought that was pretty good for a 3rd grader. And they named it. He won the competition to name the asteroid Bennu.
Very
and
cool.
OSIRIS-REx is going to Bennu. It's there. It's circling around, and it's going to return samples, we hope, in 2023. Now, the trouble with all the bosses of the solar system, the big gas giant planets, Jupiter, Uranus, and Neptune, is that they control everything. And all the little asteroids get thrown around now and then by Jupiter, Saturn, Uranus, and Neptune. And so asteroids are always coming and going in the solar system. They tend to orbit the sun, but now and then a couple get wild. So let's pretend the asteroid's going to meet Earth. Some of them, if they meet the Earth, burn up in our atmosphere. That's a shooting star. You may have been lucky enough to see a bright shooting star like that, or a meteor shower, even better. You see a whole bunch of meteors burning up in the atmosphere all at once. That's a nice thing. They're pretty. And there are several meteor showers every year. So you have a chance to see them. Unfortunately, you have to stay up late at night, but you can see.
And find some dark skies.
And find some dark skies. So asteroid meets Earth, they burn up, but some of them explode. Those that are smaller than, have a diameter smaller than 100 meters, it could explode in the atmosphere, and that's called an airburst. Now, the airburst, one occurred about 9 kilometers up from the surface of the Earth, and it occurred in 1908 in Siberia. It's called the Tunguska event. And you can see how it flattened all the trees. That's the trees flattened by the airburst. Now,
That must have been really something. Wow.
well, you'd think it would be really something. So let's put it in perspective. I'm in Maryland, which is near Washington, D.C. Dr. Monet is in New Mexico, which is not near Washington, D.C. Let's look at the Washington, D.C. area. Here's Washington, D.C. Round here. Let's pretend that Tunguska occurred centered over Washington, D.C. What would it do? It would wipe it out.
Yikes.
Yep, that's Tunguska to the scale of Washington, D.C., or the two are put on the same scale. So it was a major event. And then in 2013, a Russian fireball occurred in Chelyabinsk. And it was a 20 meter diameter meteor when it started out. And I'm going to play a little short video clip that shows the meteor vapor trail meteorite vapor trail as it goes through the atmosphere. And somebody was actually filming this. The burst occurred about 30 kilometers up, and it hasn't occurred yet. This is the vapor trail, but the burst hasn't occurred. We'll wait, and it's going to occur pretty soon. There we go.
Yikes.
And it burst windows, and about 2,000 people were damaged by the flying glass and had to go to hospitals. And let me stop this because we don't need to go on forever. There. But it was 30 times the energy of the atomic bomb at Hiroshima. So airbursts can do a lot of damage. So asteroid meets it, they burn up, they explode, and some land and become a meteorite. They're not called a meteorite until they land on Earth.
Right.
And so the term, now we have real terminology because the people who study meteorites like a lot of terminology. The meteorite is an asteroid on the ground. Most of them look like stones. So they're difficult to tell from other stones sitting around. You actually have to work pretty hard to tell if it's a meteorite versus a regular Earth stone. The chondrule is this circular thing that is a remnant of the early solar system, and they're little tiny bits that make up a meteorite, all stuck together. 5% are iron. They're rare, an iron meteorite, and 1% are a combination of stone and iron. Now I happen to bring my little baby meteorite that I've got. I don't know if you can see it. Can you see that?
Yeah.
It's iron, which means it's heavy. And that's how I can tell it's iron. If it were stone, it wouldn't be as heavy as this little piece of iron.
And is it magnetic?
No. Well, I actually haven't tried it, but it's a piece of a Russian asteroid that they've cut up in, meteorite that they've cut up into bits. So I have a little piece of it. And it's iron. I'll see, it dropped on my desk. That's iron. Some of them, as I said, contain organic compounds like sugar and water, which is interesting that they're finding organic compounds in meteorites. And on average, in case you care, if you want to dig for platinum, meteorites have more precious metals than any other ore on Earth. So that means you'd get a lot of money if you could dig up all the platinum out of meteorites, which is hard to do. Now, where do you find them on Earth? Most of them fall in the water, so we miss them. We don't see them normally, but a whole bunch fall in Antarctica. Some fall in North Africa. Oman is the tip of the Arabian Peninsula. Some fall in North America, and then every place else gets a few. This is a pie chart showing you where they land. It's old, 2013, but I wasn't able to add them all up for today. So more than 45,000 have been found, because this is an old entry from the Meteoritical Bulletin database. And if you Google that, you can actually look it up and they will tell you how many meteorites are out there. But they list them one by one by one by one by one. So you have to add them all up to me. They don't give you a nice pie chart. And probably they estimate about 500 meteorites impact the Earth every year. That's pretty good.
Question for you, Dr. Howard.
Yeah.
Do we know why so many of them are in Antarctica?
Yes, we do. And here is the picture of Antarctica. If you see the person standing there, there's a person. Look at the meteorite field. You just walk around and pick them up. The dark meteorite is easy to see against the snow.
Yeah, I think what the previous chart was showing as not so much.
Africa, because they're found against the desert sand.
Exactly.
And the dark meteorite against the desert sand.
Yep.
Same thing. So this is how they run the meteorite hunts in Antarctica. There they are measuring a meteorite. It's run by the National Science Foundation, actually, the meteorite collection. So asteroid meets Earth, we burned them up, we exploded them, we made a meteorite. The big meteorites, bigger than 1 kilometer in diameter, leave craters. And the moon has lots of craters. You're used to seeing craters on the moon, craters everywhere. The moon has been hit a lot by meteorites. But do other planets get hit? Yes, not just the moon and not just Earth. Comet Shoemaker-Levy 9 impacted Jupiter some time ago. And there's a binary asteroid, maybe, on Mars. And it's a small world on Mercury with a little Mickey Mouse meteorite crater. I normally would play It's a Small World here, but we won't do that. Here are known impact structures, impact craters on land, mostly land. And they're scaled by size, but don't worry about it. You can just see that a lot of them in North America. Here's the Amazon River Valley, where you wouldn't see impact craters very easily. And here a lot in Northern Africa, some in Europe. But once you get into the mountains of Russia, that's much more difficult to find. And in the equatorial belt of Africa, they're difficult to find because that's all tree cover. And Australia, they're easier to find because Australia is a lot of desert. So those are the known, recognized impact structures, impact craters that we found on Earth. And you may know about one of them. There's the Hoba meteorite, which is in Namibia in Africa. And it's the largest bit of natural iron on the Earth's surface. You see a human being right here, and how big what was left of the meteor when it landed and became a meteorite. And it says beware of falling meteorites. And they made a stamp, and it's now a park, a national park in Namibia. It's a World Heritage Site. And here's the meteor crater in Arizona. And I just for fun put the pyramids inside the crater to let you know about it, give you a feeling for its scale. There's the Sphinx. And here are the 3 main pyramids. And we think it impacted about 50,000 years ago, maybe. It's nearly 1,200 meters wide, almost over 1 kilometer wide, and 170 meters deep. And it's mostly evaporated, I think. Isn't that true?
Well, the meteor didn't actually strike the Earth, is my understanding, that this was another airburst.
Airburst?
And the force of the explosion was so terrific that it excavated this crater.
Okay, this was an airburst.
Yeah.
I didn't know that.
Question for you folks. Do we have any idea roughly how many asteroids have hit the moon?
Hit the moon? We could count up all
that's
the craters.
correct.
Yeah, we could count up all the craters. I've never counted up all the craters. There are more on the dark side of the moon than there are on the light side of the moon. And I don't know the total number. Alice, do you know the total number?
No, it must be in the many thousands. So, I mean, as you get sharper and sharper images of the moon, or actually visit the moon, you see little craters superimposed on larger craters, superimposed on huge craters. And
all the craters have little craters, and each crater has a crater over here and a crater over here and a crater in the middle. And
the moon has really been heavily bombarded. But the other thing about the moon is that there are very few erosive processes that would tend to either erase or cover the impact craters. So whereas on the Earth, after a relatively brief time, an impact crater is likely to be grown over, or dust will blow over it, or it'll, you know, be smoothed out by rain or wind or whatever. There's nothing like that happening on the moon. And so all the craters are still just as dramatic and sharp and easy to see as the day after they were formed.
In fact, we found craters in the last decade on Mars. New ones.
Yeah.
Yeah, so it's harder on the Earth because we have weathering. We have weather that comes in and smooths them out. We have an atmosphere that makes it rains on them and makes it harder to find a perfect shape of a crater. But for those of you on the East Coast, the Chesapeake Bay is an important resource. And it turns out that the Chesapeake Bay is formed of a crater underneath the water. About 36 million years ago, they think, the meteorite impacted right about there and sort of made it possible to fill water into the Chesapeake Bay. It didn't form the Chesapeake Bay, but it made it possible for it to fill up with water. And I think that's kind of interesting. They've mapped it out. They found the meteorite. It's underneath the surface of the water, and it's still there. Wow. Yeah. You can look at it from the side. I didn't show that image, but you can look at it from the side. And they think the original asteroid was about 3 kilometers wide. So
holy smokes.
Yeah, it was a big one. Fortunately, it was a long time ago. Now, there is an event called the Cretaceous Tertiary Mass Extinction Event. This event was a meteor strike, and it was a bad day for dinosaurs. They had a disaster plan, but it didn't help. So what is the Cretaceous Tertiary Mass Extinction Event? Actually, the boundary, they think the crater diameter is more than almost 200 kilometers in diameter, and it occurred at Chicxulub 66 million years ago. And it was a fireball again, one of these air bursts that what they think the original meteor was about 10 kilometers in diameter. And I put a map of the Gulf of Mexico over the background, and there's Chicxulub right there. That's where they think the center occurred. And if you map data, each of these points, each of these white points and yellow points and red points are data they've taken on the meteor crater remnants. And it's a gravitational map as well. So that marks the Cretaceous Tertiary Mass Extinction Event, and where we eventually, they think, lost all the dinosaurs. So we burned them up, we exploded them, we got a meteorite, the big ones leave craters. And in case you didn't know it, they're little tiny ones, less than 2 millimeters in diameter, that are dust-like particles. And tons of space dust hit the Earth every day. 44,000 kilograms of space dust hit the Earth every day. And so much hits the Earth and mostly goes into the ocean, they have to include it in climate change models. That's the little tiny, just dust particles. So that every breath you take in, you're probably taking in a piece of space dust. Actually, yikes. You're taking in space dust, but you're also taking in the element argon from the death of a star that has existed. My cat is trying to get up on the computer, excuse me. I have to kick her out of the way. But argon left that star, and with each breath you take in, you're taking in 2 molecules of argon directly from that star. It's lived unchanged since it left the star.
Wow.
So what are your chances of death from a meteorite, getting hit by one? It turns out heart disease is number one. That kills most of the people in the United States. And now opioids have taken over from car accidents and falls as the second cause of death. Car accidents, and you'll see the list here of things that can cause 1 in 6 die of heart disease, 1 in 100 almost die of opioid poisoning, falls, car accidents, various things, lightning strikes, earthquake. But look at meteorite down here at the bottom, 1 in 10 billion. So you think your chances of getting hit by a meteorite are 0 almost. Well, they're not, because it turns out somebody actually got hit by a meteorite. In 1954, this is the only authenticated incident of a relatively large meteorite about this size, actually hitting a person. She was taking a nap on her couch, and the meteorite, the 4-kilogram stony meteorite, came through the ceiling, bounced off the Philco radio that was in her room. She had the Philco radio turned on, listening, and then bounced off her left hip and arm, where it left big bruises. There is a picture of her holding the meteorite, and you can see the ceiling hole up here.
Wow.
And her name was Mrs. Hodges. She's no longer with us, but her name was Mrs. Hodges, and you can see them. She's showing them the meteorite that hit her. The police.
So we have a question.
Yeah.
Somebody was asking how many meteorites that have hit the Earth are still visible. I'm not sure if they're asking about the physical meteorites or the, craters from the meteor hitting.
Well, the craters we don't really know because they've been weathered so much that we can't find them all.
Well, they're asking how many are still visible today. How many have we found, I think?
Oh, well, we found almost 50,000.
Quite a few.
Quite a few, yes. We found people have collect meteorites, and they report them to the meteoritical database, and they've named or found or identified over 50,000. That's a lot.
And craters are not that hard to spot if you know what to look for. I have seen them on the ground when I'm flying, when I'm airborne.
Oh.
Yeah. I mean, I've studied them so long. I know what an impact crater looks like, and I have been gazing out the window and going, "Oh, there's one." If they're in an open space and they haven't been covered by a forest or a lake or something, then you can still spot them here and there. And some of them are quite striking. I mean, that's not a pun not intended.
A pun. Alice made a pun.
Sorry.
Well, because Congress got involved and said, now that we know these meteors are out there, these asteroids, we've got to find them. Somebody has to go out and look and find these ones that are near the Earth and are possibly going to hit us. And maybe there's a way to alter their orbits and kick them out of the way. Maybe. Well, once you got Congress involved, they had to get more terminology. So here's the new terminology now. There's a near-Earth asteroid, and that's something that comes closer than 4.5 million kilometers from the Earth's orbit. Now, as a reference, it's this 384,400 kilometers to the moon. So this is beyond the moon's orbit, but closer than 4.5 million kilometers, but that's considerably outside the moon. A near-Earth object is the same as a near-Earth asteroid, except it could meet other things as well. I'll give you an example of that in a minute. And then they're potentially hazardous asteroid. That's something that comes close enough that it's closer than twice the distance to the moon. So it comes close enough to maybe be potentially hazardous. That's called a PHA, potentially hazardous asteroid, or near Earth object, or near Earth asteroid. So we've got now the terminology, we can go ahead. Why are they hard to find? They are hard to find. They're very small. This is a picture that shows it's not the bright dot, it's the little faint dot right there. And they're small and they're dark. And the further away they are and the darker they are, the harder they are to find. That's the inverse square law of light. And they're moving quickly. You see this dot? It's there. And here's the two bright stars, and now it's up here. And here are the two bright stars, and now it's up here. So it's difficult to image. So it's actually rather difficult to find these things. But nevertheless, people are looking. The largest near Earth asteroid is almost 32 kilometers in diameter. And it's going to come back past the Earth in 2024 on the 13th of October. Now, I wouldn't worry about it. That's its orbit in blue. It's showing its orbit here. And there's the Earth's orbit right there. And it's going to just skim the edge of the Earth's orbit. It'll be 56 million kilometers away at closest approach. So I wouldn't worry about it. It just happens to be the biggest one we know of. Now I've got a short video clip of a meteor called 2012 DA14. And that happened in 2012. That was a while ago, but it's important because I want to show you how detailed people get when they track these things. It's really critical that everybody's paying close attention to tracking them.
It won't be long before an asteroid named 2012
Can you hear that?
DA14 makes its extreme flyby of our planet. About half the size of a football field, DA14 should come within 17,200 miles of Earth on February 15th. Although the space rock will pass within the orbit of many of our geosynchronous satellites, scientists in NASA's Near-Earth Object Program office say there's no danger of a collision. Still, they're keeping a close eye on DA14.
Even though it's getting very close, it won't reach naked eye visibility. But if you have a pair of binoculars and you know where to look, you happen to be located in Eastern Europe, Asia, or Australia, you can observe it going from the south to the north, passing closest approach over Indonesia.
Closest approach is estimated for 2:24 p.m. Eastern Standard Time Friday. NASA TV's live coverage from the Jet Propulsion Laboratory in Pasadena begins at 2 p.m. Eastern Standard Time. Later that afternoon, NASA TV will carry live views of the asteroid that may be available from observatories around the world as DA14 makes its exit from our galactic neighborhood.
And that's how closely people track this. The person who you saw talking is Don Yeomans, who is head of the Near-Earth Object Program at the Jet Propulsion Laboratory in California. And here is a picture of DA14 on the left and Chelyabinsk, the one that airburst over Chelyabinsk in 2013 to scale up in a football stadium. So DA14 is rather big. You hope it doesn't impact us. You hope it misses us, and it did. And Chelyabinsk blew up. But that's a scale of the size of a meteor asteroid as it goes by. Now, everybody's looking now. We've got the government looking. We've got university people looking. We've got a minor planet center. We've got the Jet Propulsion Laboratory, which heads up the Near-Earth Object Center. Private people are looking, private foundations, amateurs. And the thing to remember is that solutions are cheap compared to the consequences. The consequences of a meteor hitting you could be pretty bad, meteorite hitting you, but solutions are much cheaper, we think. Let's see what it takes. Actually, a private foundation that is trying to look for them is the B612 Foundation, named after that asteroid. And they were to launch an infrared telescope to find asteroids with diameters bigger than 140 meters. The telescope was to be called Sentinel, and they hoped to launch it in 2018, but they didn't make it because they haven't raised enough money. It's all private funded. They still have a website. They still are working on it. They're still trying to raise money. And of course, they say it's 100% certain will be hit, but we don't know when. So it's worthwhile looking. And the cost is not outrageous. One freeway overpass is what they estimate for the telescope. And here are the number of near-Earth asteroids found as of 2014, over 10,000. That's all NEAs in blue. Now you're all used now today seeing curves like this. Look at it go up. It's not quite exponential, but it goes up. But the large ones, the ones with diameters greater than 1 kilometer, look at the curve in red. It's flattened out. That means we found most of them, not all of them, not 100%. We've found about 90% of them so far. So it's well worth looking to find the rest of them, but it's getting harder because they're big, dark, fast, small, all kinds of different sizes. But we found most of them greater than 1 kilometer. And the curve has flattened, which is what we want to do these days, is flatten the curve. This is a picture of the Jet Propulsion Lab, which tracks the orbits of all near-Earth asteroids. And there were 10,700 of them as of 2014. And just look at that. They got to track all of that. And they do. It's just amazing to me that they can keep track of all those asteroids. And 1,460 about are potentially hazardous asteroids. This is the sun in the middle, Mercury, Venus, Earth, and Mars. So you can see they're in the inner solar system. Now, astronomers have created a scale to assess how dangerous these things could be. If the Torino scale for the Meteor asteroid is 0, that means no worries. 1 means, well, you got to look at it, but it's unlikely. That was 2012 DA14 initially, but the more they looked at it, they realized it was going to miss. Then Chelyabinsk was a 3. Close encounter with a 1% or greater chance causing localized destruction. And that's what it did. It was an airburst and 2,000 people got injured from flying glass. It gets threatening when you get up to 5, 6, and 7. And that was Tunguska in Siberia. All the trees that fell down, that's the one that would wipe out DC. And the certain collisions, this is really certain it's going to cause a global catastrophe. That's the Cretaceous Tertiary mass extinction event that was the dinosaurs, that we think did in the dinosaurs. So this is our scale we use to rank how critical they are, that we pay attention to them. Now, I want to tell you about an asteroid that's coming our way. And for all the conspiracy theorists out there, it's coming on Friday the 13th of April, 2029. Its name is potentially hazardous asteroid Apophis. And Apophis is the Egyptian word for death. And this is the Egyptian image of death as the sun god sails along at night, hoping to beat down the god of death so it can rise the next day. Now, is Apophis in 2029 going to hit us? That's the question. originally it had a rating of 4. That meant some destruction possible. But the more they looked at it, the more data they got on its orbit. The people at Jet Propulsion Laboratory showed that it comes in, it's going to come in within the orbit of the moon, but it's not going to impact Earth. It's going to be 31,000 kilometers away from Earth. That's not bad at all. It's going to miss us. So it's just uncertain that much, just that white bar. And that's its trajectory as it comes in and then it leaves the Earth. So no problem with Apophis, regardless of its name and the fact that it's coming on Friday the 13th. That's irrelevant. So what else could hit the Earth? Well, the sun could send out an ejection of particles that hit the Earth, and that does happen. That causes interference with electronics. We could pass through the tail of a comet, and we've done that. The Earth has done that before. There's a lot of debris around Earth, space debris, all the remnants of all the missions that have been sent up to orbit the Earth, space debris, and now and then a fallen rocket part. So yeah, other things could hit the Earth. Mainly it's meteorites, but there are other things that could happen. So what do we do to protect against this? And it turns out the students at MIT put together a project to say, how can we get rid of a meteor, an asteroid headed our way? And their project was to blow it up. And it inspired the 1979 movie Meteor. If you saw that movie, if you haven't, don't watch it. It's just scary. And it's probably not likely to happen. But the trick is that it has to be the whole world involved. This can't be one government doing this all on its own. There's no one government that says, I'm going to catch all the asteroids. Everybody has to get involved in this. And it was begun in 1999. And so what do you do? What do you want to do if you want to? 3 most important things to do. Find it early. That's very important. You've got to find it early. The second most important thing you've got to do is find it early, because you really need to find it early. And the third most important thing is, you know it, find it early. Yes, that means search and identify these asteroids headed our way. And we found 90% of the big ones. So we're doing pretty well, but we're not quite there yet. So what can we do? There's actually sound on this. We can find it. We can kick it. We can blow it up. We can push it. Or we can use lasers. These were concepts that people are working with, and we don't know if any of them will work. You can kick it. This is kinetic impact. And here's a picture of a mission built to kick an asteroid. And we actually did that once. We set up the deep impact mission, and it dropped a piece of itself down on the asteroid to kick it. And they wanted to watch what would happen to the asteroid after it kicked it. Not much. It blew up some dust, but it wasn't big enough to do a whole bunch of damage. The trick is you want to kick it hard enough to deflect it out of its orbit. You can do this if you find it early enough, because it takes years to decades of warning to build the mission you need and to get out to the asteroid and kick it. You got to find it early. You can blow it up with a nuclear weapon. That's harder to do because it takes a lot of warning to build the weapon, build the mission, blow it up, and you got to make sure you blow it up in such a way that none of the pieces come back to Earth. You don't want to have a nuclear holocaust descending on Earth. So you got to be careful about it. You can send up a mission to use gravity to tug it out of the way. This is very slow, and it takes decades of warning to build the mission, get out to the asteroid, and slowly tug it out of its orbit. That maybe is the least harmful to the asteroid and to us, but it takes decades of warning. And laser beads. This is very difficult to do. You send up a bunch of lasers, here they are, and they pound the asteroid, pung, 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 and they do it enough that it kicks it out of the way. That's laser beams. It's very difficult to do. I don't know that, Alice, have anybody even thought about that one?
This one is new to me. It's fascinating.
Yeah, well, the asteroid missed us this time, and Mr. Grumpy Cat says there's always next time. I like Mr. Grumpy Cat. So I put in Mr. Grumpy Cat. Now, are they always bad news? And of course, the dinosaur over here is saying it's pretty bleak. Climates are changing, mammals are taking over, and we all have a brain about the size of a walnut. So are they really all bad news? Well, that person you heard speaking on asteroid DA14, Don Yeoman, said, we human beings likely owe our existence and current position atop the animal food chain to these space rocks. And you see here the winner. As the dinosaurs have been done in by the Cretaceous Tertiary mass extinction event. So what can you do? What can you do to help with this? Well, you want to eat right. That's the heart disease part. You want to wear your seatbelt. That's the don't get in a car accident part. And support astronomy, of course. That's the most important thing you can do, is support astronomy. And this is my last slide. This is the National Academy of Science has a free report you can download. It's still available, Defending Planet Earth. And it talks about all these possible ways that people are trying to do it. And the Near-Earth Object Program at the Jet Propulsion Lab, this is its URL, neo.jpl.nasa.gov/neo. And you can always ask your friendly local astronomer at the Arlington Planetarium. Yeah.
Excellent.
Yeah. So remember, don't panic and always carry a towel. That's it. Now, are there any more questions? Because people had good questions. Sorry, that's me.
Oh.
My computer. And it knocked you guys out. I'm going to take this off and close it out and stop sharing it.
You're not sharing.
Oh, good. There we go. Questions from everybody out there, or did we handle them all? Maybe we didn't.
That was great, Sethanne. That was a very nice review.
So question for you, you talked about 10,700 objects. Were those all asteroids or some of those space junk that you were talking about?
No, they're all asteroids. They separately track the space junk. That's a different tracking bunch of people. They separately track the space junk, and they've got people tracking that in the Air Force. We'll hang up my phone and and come on, it's supposed to hang up. I know, I got to answer it and then hang it up. There. Yes, those are all asteroids.
So also, because we had you in such a small window on the screen earlier, can you show us your little meteorite?
Yes. Is that a better view?
Oh, that's great.
That's
what is that one made? What is that one made from?
It's a piece of a Russian larger meteorite, and it's a piece of it. It's iron. This is an iron meteorite. It's heavy. If I gave it to you, you'd feel the heft. It weighs more than a stony meteorite would weigh.
That's a really nice sample. It looks like it might have a little nickel in it as well.
It might. It's kind of pretty. I don't know if it's magnetic. I don't think so. Oh, I take that back. It's magnetic.
Yep.
Yeah, it's not strong enough to pick up the scissors here, but I can see it's trying to.
Yeah.
Trying to pick them up. So it's slightly magnetic, like iron would be. Well, like iron is.
So this brings up two of the qualities of meteorites that make them, that enable people to identify them when they find them. If you're on a walk in the woods or wherever and you spot a rock that looks somewhat different from other rocks, one way that you can test to see if it could be a meteorite is simply to pick it up and see how heavy it is. And if it's dense and it feels heavier than most other rocks its size, that's a clue. And then if you're a total nerd, like some of us astronomers, and you happen to carry a magnet around with you, you can check to see if this heavy rock is magnetic, or take the rock home with you and see when you get home if it's magnetic. And if you find rocks that are both super dense and magnetic, there's a good chance that they are meteorites. You can take them to your local university astronomy department or geology department and have them tested for you.
And then they will report it as a found meteorite.
Right.
So it goes into the massive database of all known meteorites.
Right.
A lot of people collect them.
Yep.
And they have names. If you cut up a meteorite into slices like this, planes, they have names for everything you might see, different names for different slices. It's amazing. They've got them very detailed. Any other questions? Or is everybody tired?
I'm not seeing any other questions at this point in time. So I don't know, do you folks have any last thoughts or comments regarding asteroids and meteorites?
Well, I wouldn't worry about it. People are out there looking, and don't worry. You don't need to worry. Ask your astronomer if you've got questions. That's what you need to do. Don't panic. We got enough to panic about.
Yes, we do.
Okay, well, I want to thank Sethanne Howard and Alice Monet for joining us today. Again, we're the Friends of Arlington's Planetarium. We hope that you've enjoyed it, even though it was a little tough to get it started. We hope that you found out something new today. And we hope that you will tune in the next time we give another talk. And, you know, happy isolation time for everyone out there.
Yeah.
Okay. Thanks, Kathy.
Bye-bye.
Bye
Thanks.
now.
Bye.